In this example, we see return loss failed again, similar to another result. The red asterisk indicating it's a marginal fail, but again, a fail is a fail. If we tap on return loss, what we see here is all four pairs, and again, we want to see which is the worst performing pair. So if I tap here next to pair, it's going to automatically jump to the worst performing pair, the pair that caused the fail, or actually the marginal fail of minus 0.9 dB. And in the top left hand corner, it tells me it's pair 7/8. Now there is some information that can be obtained from this screen when you look at it. Now, if you see my other DTX videos on return loss diagnostics, you might recall that I say if it fails at the lower frequencies, that can suggest that there's a cable issue. What is lower frequencies? Anything less than about 50 megahertz. When we look at this and we look at the cursor where it's gone to the worst place, it's 30.8 megahertz. So that would suggest maybe this is a cable issue. So we're going to go back to the home screen. Now, because it failed at the lower frequencies, there's always a possibility it's a DC contact resistance issue. So we're going to tap resistance and make sure that all of these four pairs are roughly the same. Of course, they're not exactly the same because you've got the different twist rates in the pairs. On a longer link, you'll see more separation between the pairs. So as long as they're not more than about 1.5 ohms or 2 ohms difference between the pairs, then you know you don't have a DC contact resistance issue. So everything is pretty much the same here, so we don't have a DC contact resistance issue. Let me tap on diagnostics. We've got our HDTR Analyzer, our high definition time domain reflectometer analyzer, or return loss. That's the tool that we're going to use here, which allows us to look down the cable and see where the impedance anomalies are, the ones that are causing the return loss. Now we only want to look at the pair that caused us the problem, which was pair 7/8. So I'm going to tap the pairs until I see pair 7/8 appear in the top left hand corner. Now when you look at this, you might just be able to see some activity in the cable there, but again we need to zoom, so let's just go ahead and zoom. How much do you want to zoom in? I like to zoom in until I see the vertical scale change to 1/2. Bring that across so I see the whole trace. And now I'm actually looking down the cable and seeing where the impedance anomalies are. Now you're always going to get some. The question is what is acceptable and what should you be concerned about? Again, from the previous videos, you'll probably know by now that our general rule of thumb is 0.8 or minus 0.8. So let me magically draw in the 0.8 line again and the minus 0.8 line. And we can see that we have multiple events that far exceed that 0.8% guideline. So the frequency domain suggests it's a cable issue. The time domain also confirmed that we have a cable issue. And of course, whose fault is it? Is this badly made cable, or is this cable that got damaged during the installation? I make a point of not saying that. However, when you look at this trace here, you'll notice that there are segments of the cable which are far less than 0.8%, but there are other parts of the cable which exceed it by a noticeable amount. If the cable was made badly, you'd expect it to look bad all the way down. When you only see certain segments of the cable, you could be forgiven for suggesting that maybe this was something done during the installation. Unfortunately, with this one here is whose fault it is, but this cable is going to have to be replaced.